Effing way.
Yes, we lost, but that's okay. We had fun. All right, so we need to be used to different values that are gathered in calculus. We have x values, we have f of x values, and we have f prime of x values. F prime of x refers to the slope at that point, okay? Whereas f of x refers to the y value, and x is obviously the x value. So that's how you interpret this data. And so we're just going to answer a few of these questions here and kind of understand what's happening with the data. It says find the average rate of change over the interval -2 to 4. Average rate of change we calculate by finding slope. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So we've known how to do that. That is what we refer to as average rate of change over an interval. Okay? So what's y sub 2? 6. What's y sub 1? 20.
Wait, no, it's not. Oh, wait, it's not.
Yep. So we're doing 6 minus 20 over 4 minus -2, and we get -14 over 6, or -8/3. So as a whole, this function is dropping.
That's not right.
-7/3, excuse me. Thank you. I want you to talk to the person next to you over what two consecutive integers is the average rate of change the greatest, and over what two consecutive integers is the change the least. Talk to your peers, see if you can figure that out. Go, talk.
Between -10 in what?
2 and 3. So one.
Or what?
No, 2 and 3 and 1 and 2. So one.
Yeah, maybe 10 to 6. That's 10 plus 6.
No.
Oh, so what's your x value? Thank you. And then -1 and -2, and then 1 and then 2 and 3.
Wait, 5, 4, 3, 2, 1. Can somebody tell me where it's the greatest? Yeah, -10 to 6. So over the interval of 3 to 4, that's when it's the greatest. Yeah, greatest is when it goes from -10 up to 6. That would be your greatest increase. All right?
Oh, so you meant 3.
So then how about the least?
2 to 3.
You said 2 to 3. Why? Because it just dropped what?
2.
Just dropped 2. Well, here it drops 10. Isn't that change -10? Isn't that less than -2? You get my point?
Yeah.
So as you order it, it's not about which one is closest to 0. It's not about, if I said what is the least steep or something like that, then I guess you could say, well, from 2 to 3, it's least steep. But without a doubt, your least value is going to be this drop of -10, right? That's furthest to the right or furthest to the left on the number line. Everybody see that? Okay, a little bit of a trick question there. Okay, if we were to order those from least to greatest, again, -10 would be way over there, and then so on and so forth. Question C, what is the instantaneous rate of change? Notice the difference between instantaneous and average. Average uses 2 points. That's where we refer to the secant line. But when you see instantaneous, that is at 1 point. That is the derivative. The word instantaneous and derivative mean exactly the same thing. Instantaneous rate of change for the function at x equals 1. Instantaneous rate of change of the function at x equals 1 is, anybody? -5. That's the y coordinate, that's the slope. It is -5. Same exact question, just worded differently. What is the derivative of the function at x equals 3? Yeah, -3 is the derivative. We're going to ask the exact same question again. What is the equation for the line tangent to the function at x equals -2? What two things do you need to write an equation for a line? You need a point and you need the slope. Well, at x equals -2, what's the y value? 20. What is the slope? -12. So -12, the slope of the tangent line, that is the instantaneous rate of change. It is the derivative. They all mean the same thing. Okay? Everybody see that?
Mhm.
Once you had it in this form, would you know how to write an equation for a line?
Yeah.
Okay, so we can move on from that, so we can go see the dogs.
Yes.
Not those ones.
Oh, okay, all right. Thought I'd get a little bit of laugh.
That's so
Okay,
funny.
flip it over. So we want to get through this page today. It says sketch a graph of the function that satisfies the following. We want a graph. There's an infinite number of answers for this. It says f of 0 is equal to 2. It says f prime of 0 is 1. It says f of 3 is 0. And f prime of 3 is -3. What does f of 0 equals 2? What does f of 0 equals 2? What does that mean? If for an x value of 0, you have a y value of 2. So I know it goes through the coordinate 0, 2. Everybody okay with that? So that's an absolute must. I have to have that. And then, what does f of 3 equals 0 mean? At 3, I have a height of 0. So it crosses the x-axis at 3. Okay? Everybody okay with discerning those? Now the next thing is, it says f prime of 0 is equal to 1. What does that mean? Yeah, so I'm going to use a different color here. So that means the slope just right at that spot is equal to 1. So right at this spot at 0, okay, at x equals 0, I'm going to have a slope of 1. So I'm just going to draw a little green line that shows me I have a slope of 0. Excuse me, of 1. And then f prime of 3 equals -3. That means at 3 the slope is -3. So I'm going to approximate a slope of -3 right at that spot. So there's an infinite number of graphs that you could draw that satisfy these requirements. I'm just going to draw one graph. Okay? Here's one graph that satisfies those requirements. Everybody give a round of applause when it comes to that. Yeah. Doesn't she look amazing? I'm wondering, like, if we went to high school together, would she let me eat at her lunch table? I think she would go look cool for me.
You would be a like.
Maybe if you're, maybe if the dogs were put away, then yeah.
They're frightened by my feet. Yeah.
Yes, I see why.
If we finish our lesson today, we get to go down and view the new puppies.
Yeah, they are precious.
Yeah, so that's what we're gonna
Saw
do.
him this morning.
Oh wow, I see who's more important here.
She walked by as I was bringing them in.
You never told me.
I didn't know until this morning.
What up?
You keep fighting.
All right. Next one, sketch a graph of a function that satisfies the following. I want you to try this one on your own. Go ahead. You try this one on your own. See what you come up with, okay? Again, there's an infinite number of responses. I'm just drawing the one that maybe seems most common to people.
Sorry.
People are kind of putting stuff together. I'm going to put some of this up here. I got something like that. You guys okay with that? Okay. So part of the key that we want to be able to do in this situation is to understand the difference between F and F prime. That's a very common question people have. I think it was a question asked possibly yesterday by Lily. Does everybody understand now the difference between F of and F prime?
Yes.
Okay, so that's, as I said, that's very important confusion. I just want to make sure it's gone. I think we did a good job of addressing that yesterday. So the last piece we want to do is be able to interpret the derivative in terms of real world context. And this really shows whether or not you have an understanding. It's important that if you see a different way of expressing these answers, you let me know to see whether or not they would satisfy the requirements. Because I've had many people that are convinced that they know what the derivative means, but what they write here is absolutely wrong in every way, shape, and form. So please pay very close attention as we talk about this first example here, and you guys will try one on your own in a second here, okay? So, temperature of a pot of water is modeled by a function. Hi there. Doesn't she look amazing today?
Actually, no, you're disrupting our time.
No, we gotta go see dogs.
You gotta go.
Okay. No, real quick, three
We're
favorite
boxes.
things about Kendra. Who's got a favorite thing about Kendra?
Oh my
Okay,
God.
Let's go. What do you
She
got?
is
You got
hilarious.
Jordan.
School spirit.
Jordan, school spirit. What else you got?
She's hilarious.
She's hilarious. What
Wow.
else you got?
Eyelashes.
Eyelashes.
I'm always
Kendra, 1, 2, 3. Thanks for
you,
being
guys.
here. Okay. Temperature of pot of water is modeled by this.
You too.
So we're going to say that the temperature in Celsius, okay, is a function of the number of minutes. So let's just understand there. What do you think happens to the temperature as the number of minutes change? It probably gets hotter. I mean, we're trying to boil the water, right? That's what's happening here. So this just means that Celsius, or the temperature in Celsius, is a function of minutes. So minutes is our input, Celsius is our output, okay? It says, explain in simple terms what F prime of M means. So this is the derivative, or the rate of change. And what it means is this. The rate at which the temperature is changing. Okay, so the rate at which the temperature is changing, so this piece right here will always be the y, or the function, or the output, okay? The rate at which the temperature is changing at time m minutes. Okay, so this is always the x part right here, okay? The rate at which the temperature is changing at the time x minutes. So let's interpret it then in terms of f prime of 5 is equal to 10. What that means is the temperature is changing what? The temperature is changing. What's the measurement for the temperature at which it's changing? How fast is it changing? 5 is the time.
It's at 10.
Temperature is changing 10 what? Degrees?
Every 5 minutes.
Celsius.
At 5 minutes. Like
The temperature is changing 10 degrees every
5 minutes.
minute. This is 10 over 1. The temperature is changing 10 degrees per minute. A derivative always has a rate attached to it. Always attach the rate, degrees per minute. The temperature is changing 10 degrees per minute at what? At 5 minutes. Here are some misleading statements that people make. They say, over the course of the first 5 minutes, the temperature has increased 10 degrees. Absolutely false. You have no idea how much it's increased by that time. It maybe went down. Maybe somebody dumped some ice in it for all we know. You have no idea. But what you know is that right at that time of 5 minutes, you're expecting that if you took the temperature again in about a minute, it would have gone up about 10 degrees, okay? Because, it might be climbing more quickly or more slowly, but at that time, it's going up by that amount, okay? See if you can express this next one, both these pieces right here, okay? Try that on your own, okay? Think that through. We'll do one more after that, and then we'll go see dogs. So this will be about 5 more minutes. And then tomorrow we have a very algebraic lesson, very algebra intensive. See how good your algebra teacher was last year. I'm going to put my shoes on, my plantar fasciitis is kicking in. Sometimes you figure out why certain parents didn't show up to conferences. Em and Jordan, you guys want me to make those t-shirts?
Sweatshirt?
Yeah.
Yeah. Maybe we should bring it up to the whole class. Have we brought it up to the whole class?
Can we have our last names on the back?
Last names on the back?
Or like 24 on the back?
Yeah, I'll try to get the cost down like $10 a t-shirt.
Okay.
Would you want to do $10 a shirt?
Yeah.
I'll talk to some powers that be. What's max you'd be willing to go?
I don't know, we're paying 20 for all our shirts right now.
I promise I can do, I know I can do under 15.
Oh, yeah.
Might end up being 12.
Yeah,
See
that
what-
works.
Okay.
Mind, Becca?
No, you're not in our class.
You're not
Get
cool enough,
out.
Hannah. Remember your flex broke up with me and I'm really sad about it.
Yeah, because you're like to get us back.
Hey, we're getting pretty fun.
All right, the
We got
rate
people, we're fine.
at which, what is changing? The rate at which the distance is changing. At what?
Time. Hours.
At time H hours. Let's just talk about the obvious here. The derivative is simply the runner's speed, is it not? It's simply his miles per hour. Every single time you're driving in a car, if I call, where are you driving to next, Emma?
I will be driving to the museum.
You'll be driving to the museum. Excellent, okay? What's the fastest you drive when you're headed to the museum?
45.
45. And when is that in your trip? How long does it take you to get to the museum?
2 to 3 minutes.
Okay, so 3 minutes. So at time 2 minutes, she's driving 45 miles per hour. Would that be a possible statement?
Well, I'm not driving 45 the whole time.
Right. But at 2 minutes, she's driving 45 miles an hour. That's reasonable
Yeah.
within that context. Does that mean she's driven 45 miles?
No.
Does it mean she drives 45 miles an hour the whole time? No, but at 2 minutes, if she looks at her speedometer, reads 45, that's the derivative. You see derivatives every time in your life when you see that calculation, okay? And so what does it mean? F prime of 3 is equal to 5? Well, we could write it the complex way. You could say the distance is changing at a rate of 5 miles per hour at time 3 hours. The other way to say is just at 3 hours, the runner is running at a speed of 5 miles an hour. That's all that means. Sure, I would discourage you from saying after a certain amount of time has passed, but specifically at the time 3 hours. At that moment in time, if you were to take a snapshot of them at that single moment in time, that's their speed. Okay? Last one. Mass of radioactive isotope is modeled by G equals F of D. G is a mass measured in grams, and D is time measured in days. Okay? Does everybody understand? Have you talked about radioactive decay and stuff in your science classes? Okay, so a little bit. So sometimes you get a radioactive material that's decaying, and we try to find like its half-life, or a certain amount of it left. Well, this, if you look at the descriptor, G is equal to F of D. So G is measured in grams, so that's the mass, and then D is the number of days. So the rate at which what is changing? The mass is changing. At time D days. You go ahead and write part B on your own. I should see the mass is changing at a rate of negative 0.34 grams per day at 2 days. If you chose to say the mass is decreasing at a rate of 0.34, okay, if you want to say it's decreasing, that's just fine. That means you used up your negative, right? So that's kind of the language. Does this mean that it has lost 0.34 grams so far? No, you don't know how much it's lost so far. All you know in that single point in time is that it is losing at a certain rate. That's all you know at that moment. That snapshot, that picture. So that should be able to help you out with the rest of your assignment as you look through it. And tomorrow we have a very algebra intensive day. Let's stop this video and let's go see some puppies.
Bring her back.